So, taking a look at more imaginary numbers. So in these first ones, we're just solving. Well, how do we solve something like this? We simply take the square root. But if we take the square root of x, we get, or of x squared, we get x. Well, what's the square root of negative 68? Well, that negative, right, we'd pull out that square root of negative 1, and that would just turn into I. But we can still simplify this. So 68 would be, 2 and 34, which would be 2 and 17. So I've got two 2's, so I can take one out of the radical. I eliminate one, and I've got 17 left inside. So x would equal 2i square root of 17. That's as simple as I can get it. On number 2, same idea. You take the square root of both, you get a equals square root of negative 55. I know that negative is just going to turn into I, so I'm really focused on just the 55, which is 5 times 11. I don't think there's anything we can do with that, is there? So it would just be a equals I square root of 55. Okay, so that's basically what we're doing on all of these. Okay, so we got those two done. So this square root of negative 33. So I know it's going to have some number, an I. Well, 33 is like 3 times 11. I don't think there's anything we can do to that one either, is there? Which sometimes happens. Okay, 18. Take the square root of both sides. X equals square root of negative 18. I know that's going to be I. 18 is 2 times 9. We know the square root of 9 is 3, right? So it would be 3i square root of 2. Okay, 5, take the square root, v equals square root of negative 99. Negative would be I, 9, and 11. That would become 3. So 3i square roots of 11 is what v would equal. Okay, this one, number 6, take the square root, x equals square root of negative 75. That would be I. 75 is 3 times 25. We know the square root of 25 is 5. And we'd be left with the 3. Alright, so now the last 4. Square root of x, square root of negative 9. Well, we know the square root of 9 is 3. And so we know that that negative would make an I. And I suppose since we're getting the square root of some of these, we should probably think of that as positive and negative 3i, right, because of the square root. So all those answers we wrote should probably have a plus or minus, unless we just left it, we couldn't put a coefficient out there, we couldn't put a number out front. Then it wouldn't need the plus or minus. I mean, we still could do it, but it's kind of up to you. So take the square root of that, we get r equals plus or minus. Well, I know that negative is going to give us an I. What's the square root of 78? Well, we can simplify that with 6 and 6 would go into 7 once. 1 left over. 13. Yeah. 6 and 13, which 6 can be 2 and 3. There's nothing else we can do with that one, right? So I suppose you could write it like that. Okay. Number 9, square root, so x equals something I, square root of 89. What would that one be? Can 3 go into that? I don't think so. 4 couldn't. 5 couldn't. 6 couldn't. 7, nope. 8, 9, 10, 11. Is there nothing that will go into 89? Nope. So we put our answer down like that. Number 10, take the square root. So a would equal, that negative would be I, square root of 8, 2 and 4. We know the square root of 4 is 2. So would be plus or minus 2i square roots of 2. Alright, so now we're going to get to the hard stuff. Now we're going to factor each expression over the complex numbers. So basically we're factoring, but we're not going to end up with nice, neat, easy looking numbers. Okay. So number 1. So our normal method of factoring, right, is using that box method. That's one way anyway, especially on these more simplified ones. So we'd say x squared, we'd say 5. Well, what are the factors of positive 5, basically 5 and 1, or negative 5 and negative 1? Do any of those add up to 4? No. See, this is where we run into our problem. So the best way to attack these problems is using the quadratic formula. So the quadratic formula, remember, is the opposite of b plus or minus square root of b squared minus 4 times a times c over 2a, thinking ax squared plus bx plus c. Okay, is that standard form? So using this helps us find the roots, right? That's what the whole quadratic formula is all about. So a would be 1, b would be negative 4, c would be 5. So then we just go the opposite of b, so that would be a positive b, because a negative and a negative make a positive, plus or minus the square root of negative 4 squared, which would also be positive, minus 4 times a times c over 2 times a. Then we would simplify that. Okay, so I'd get, and basically I want to simplify that radical first, right? What we call underneath there is called the determinant. It tells us a lot of cool stuff. Negative 4 squared is 16 minus 4 times 1 times 5 is 20. 16 minus 20 is negative 4. See? Now this is going to be, because we have that negative under the radical, we're going to have an I. We're going to have an imaginary number. So I've got 4 plus or minus the square root of negative 4 over 2. So do we know the square root of 4? Yeah, it's 2. So we'd separate that like to negative 1 times the square root of negative 4, or a positive 4. That would simplify to 2. That would simplify to I. The whole thing would be 2i. So you get 4 plus or minus 2i over 2. Now, 4 is like 2 times 2. So there's a 2 here and a 2 here. I can cancel the 2, and I'm left with 2 plus or minus I. Okay, so that gives me two factors, right? 2 plus I and 2 minus I. Okay, which that's what it wants us to get. That's the result, and you could have left it either way. You know, those are our zeros. Okay, those are our zeros. So that's really what it's going to come down to doing on this. Okay. Alright, so I placed a non-written version of it, just so we have it there. So, that's all we're kind of just going to work through. So, A for 1, negative 2 for B, C is 10, so I go x equals the opposite of B, so a negative, negative 2, that's why it turns into a positive, square root of negative 2 squared minus 4 times 1 times 10, that's A and C, over 2 times 1. So simplify the radical first. So I'd get negative 2 squared is 4, minus 4 times 10 is 40. So we'd have negative 36, which would simplify to square root of 36, which is 6, the square root of negative 1, which is I, so 6i. So that plus or minus takes care of the plus or minus of this 6. Okay? So negative negative would make that a positive, plus or minus 6i over 2. So now, those can cancel, but we've also, because of the plus or minus, got to cancel both. So we'd end up with 1 plus or minus, what's left over? 3i. So there's our answers. And remember, that's two answers, okay? Two complex numbers. So basically, most of the time when you have one complex number, you're going to have that second one because of the plus or minus concept. Okay, now let's look at number 3. A is 1, B is 4, C is 8. So it would be negative 4 plus or minus square root of positive 4 squared minus 4 times A times C over 2 times A. Okay, so we simplify that. 16 minus 4 times 8 is 32, which that would be negative 16. So square root of 16 times the square root of negative 1, you separate them. That's I. That's plus or minus 4. So we get negative 4 plus or minus positive 4i over 2. Once again, those cancel, leaving us 2, right? Because 4 divided by 2 is 2, so we get negative 2 plus or minus 2i. And there's our answers. Okay, so there's our imaginary roots, which is what we were striving at here. Okay, moving on to number 4, A, B, and C. So negative 8 plus or minus square root of 8 squared minus 4 times A times C over 2 times A. So I know it's over 2, negative 8 plus or minus. Well, now what's going on here? So 8 squared is 64. 4 times 17 is 8 to 68. So we get negative 4. So square root of 4, square root of negative 1, that's I, that's 2, plus or minus 2, I. Simplify that, becomes 4, simplify that, becomes 1, so we get negative 4 plus or minus I for our answer. Okay, so once you see using that quadratic formula is really not too bad, is it? Okay, number 5. So 1, 4, and 7. So same thing, negative 4 plus or minus square root of 4 squared minus 4 times A times C over 2 times A. So this simplifies and gives us 16 minus 28, which 16 minus 28 is negative 12. Yeah. So square root of negative 12, so we get square root of 12, square root of negative 1. So we know it's going to have an I. Now, square root of 12. Well, that one's going to be 4 times 3. We know the square root of 4. So it's going to be 2 times I times the square root of 3, because we won't be able to take that out. So we get negative 4 plus or minus 2I root 3 over 2. You can still simplify. That becomes 2, that becomes 1. So I'm left with negative 2 plus or minus I square roots of 3, which is still my answer. Because that square root of 3 is like a decimal, it's a number. Okay. So now let's take a look at number 6. Now number 6 doesn't appear to have all our stuff we need, does it? Okay, so really we could make it x squared plus 0x plus 5 and try to do it that way. Or we could just say x squared plus 5 equals 0, right? Because that's essentially what we're doing with all of these. Okay, we could say that's equal to 0. Okay, that same thing with that quadratic formula. So I'd subtract 5, get x squared equals negative 5, take the square root, and I've got x equals plus or minus, well, square root of negative 5, square root of negative 1 is I root 5. So it would be plus or minus I root 5. Okay, so number 6 and 8 basically got the same thing going on, don't we? So I don't know if we'll need the quadratic formula for some more of these. So x squared plus 6 equals 0. I guess it wanted us to factor, right? So do we need to? Alright, so looking at these, we just want to solve them, because once we've solved them, if we wanted to, we could write out the factors, okay, just by going backwards, which I suppose is what we probably should have been doing. But to me, finding the x-intercepts is the more important part, so that's kind of why I focused on that. So anyway, looking at this one, we'd have the square root of negative 6, which I know I can't simplify other than making it I root 6. okay, plus or minus. So if I wanted to factor this, okay, basically it would be, x minus I root 6, x plus I root 6. Okay, that's essentially what we'd end up with by looking at this, because that positive or negative would translate to this, and we just work backwards. Since we have both, we have one of each. Okay, so all those problems when we had something like negative 4 plus or minus 2i. If you wanted to turn that into a factor, you just go x minus 4 plus 2i and x plus 4 plus 2i. Okay, so that's how we would just turn it into a factor. So that works too, or just finding the root. Okay, number 8 basically would turn into number 10, right? Because we'd go x squared plus 8 equals 0, subtract 8 from both sides, x squared equals negative 8, take the square root of that, and we found that that was plus or minus 2i root 2. So once again, if I wanted to make those factors, it'd be x plus 2i root 2, x minus 2i root 2. Okay, if we wanted to turn it into factors, now we could multiply it out, and you'd come up with that same thing. Okay, now number 9 is different, right? Because on number 9, now we have, if you remember when we talked a little bit on one of the homeworks about those special products, well, this is the sum of cubes, because 27 is really 3 cubed. So with the sum of cubes, the way it works is you take those two numbers and you go, let's see, it's plus, so we would go x plus 3 times x squared minus 3x, 3 times x, plus 3 squared. Okay, so we'd have x plus 3 times x squared minus 3x plus 9, which this could be simplified further, right? And that would be x, let's see, now we might need to use the quadratic formula on that one, right? Because factors of 9 would add up to negative 3, yep. So this is where we kind of have to combine the two ideas of new rule and then that quadratic. So opposite of b plus or minus square root of b squared minus 4 times a times c over 2 times a. And it's just this one that we have to factor out. So that becomes a positive 3 plus or minus over 2. Okay, now let's do this in a different color. Negative 3 squared is 9 minus 4 times 9 is 36, which would give us negative 25. So square root of negative 25, which would be 25 is 5, negative is I. So it would be plus or minus 5i. Now I can't simplify that one at all, can I? That 2 doesn't go into the 5 very easily, or into the 3. So what would happen here is, to write out in factored form, I'd go x plus 3 plus or minus 5i over 2 times x minus 3 plus or minus 5i over 2. So our roots are negative 3 and then 3 plus or minus 5i root 2. So there's 3. 1, 2, 3 roots. Okay, 1 real, 2 imaginary. Hideously looking imaginary. Okay, that's number 9. Okay, now number 10. I think we got the same idea going on here. Okay. So, we've got that cube here on number 10. So to factor it, we use that. That's like x cubed minus 4 cubed. So, we would use the difference of cubes, which that one looks like this. X minus 4 times x squared plus 4x plus 4 squared, which is 16, right? once again, there's no way to factor that longer one out, so we're going to have to use the quadratic formula. So the opposite of b plus or minus square root of b squared minus 4 times a times c over 2 times a. So we get that's 16 minus 4 times 16, which would be 64. 16 minus 64 should give us a good number. Gives us negative 48. So square root of negative 48. So how do we simplify that one? Well, we know we've got the I from this negative. 48 is 6 times 8. No, there's a better one. 48 is 3 times 16. Yeah. So 3 times 16. Well, we know the square root of 16 is 4, so I'm going to have 4i square root of 3. Ugh, that's ugly. So negative 4 plus or minus 4i square root of 3 over 2. That cancels the 2, that cancels the 2. Remember, because of the plus or minus, I have to do it twice. So we really have negative 2 plus or minus 2i root 3. Okay, so those are, if we turn those into factors, we have this x minus 4 times x minus 2 plus or minus 2i square roots of 3 times x plus that whole thing. Because we've got two of them, plus or minus 2i root 3. So there's our factored out form. That gives me, oh, I shouldn't have put plus or minus, huh? Oh yeah, I should have. Plus, so positive 4 for one root, then 2 plus or minus 2i root 3. Okay, for the roots, I don't know why I put equal there. So what that means is if we graph it, we will be able to see this root, we won't be able to see those roots. That's basically what it comes down to. Alright, now, same idea for number 11. Okay, so they're taking a long time, aren't they? So we'd get, this is the adding one, so we'd get x plus 1 times x minus x, x squared minus x plus 1 squared, which is 1. Okay, so once again we'd have to use the quadratic formula here. So the opposite of b, so that's like a 1. So positive 1, because negative 1 is positive 1, plus or minus 1 squared minus 4 times a times c over 2a. So I get 1 plus or minus 1 minus 4 would be negative 3. So I root 3, because that negative we could pull out, that's the only thing we could, over 2. So those are our two factors. So in our answer we'd write x plus 1 times x minus 1 plus or minus I square root of 3 over 2, and x plus 1 plus or minus I root 3 over 2. Super ugly, aren't they? But that's where we gotta go with. Alrighty. So number 12. Now we got the sum and difference of squares. Okay? Because that 4x squared minus 25 is like 2x squared minus 5 squared. When we have that, it's 2x plus 5 times 2x minus 5. Okay? Now, x squared plus 9, the way we'd have to factor that one out is basically we could go backwards and we get x squared equals negative 9, which take the square root, x would equal plus or minus 3i. So basically we're going to have 2x plus 5 times 2x minus 5 times x plus 3i times x minus 3i. Okay? So we've got two real factors, two real zeros I mean, and then two imaginary zeros. Okay? Which is what we'd end up with. Okay, 13 is going to be very similar. Okay, this one, we can just go, we can work it backwards. we'd subtract 4, right? If we did x squared plus 4 equals 0. And then we would take the square root, so we'd end up with x equals square root of 4 is 2, plus or minus. Square root of I is I. So we've got two factors, x minus 2i, x plus 2i. Then we've got to figure this guy out, which didn't we already do that guy? I swear we did. Oh well. So, we end up using the quadratic formula. So negative 5 plus or minus square root of 5 squared minus 4 times a times c over 2a, which is 1. So negative 5 plus or minus over 2, that would be 25 minus 24, which would be 1. So square root of 1, which is 1. So negative, so this one we could have solved, could we? No. No, we could, yeah, we could have. Dang it. Could have factored that one a lot easier, because see how negative 5 plus or minus 1 over 2? Well, negative 5 plus 1 is negative 4 over 2 is negative 2. Negative 5 minus 1 is negative 6 over 2, which is negative 3. So I've got two real factors here, which basically just tell me if I'm factoring this whole thing, could have just done the box method. Angry at myself now. We'd have x plus 2 and x plus 3 for our factors. 2 real, 2 imaginary. Which would give us our zeros, right? Alright, now 14 and 15. Okay, this one, x squared plus 3 equals 0. Subtract that. X squared equals negative 3. Square root. X would equal plus or minus I root 3. So to my factors, x minus I root 3, x plus I root 3. Okay, the other ones, let's use the quadratic. Opposite of 12, so it's negative 12, so negative and negative would make positive. Square root of negative 12 squared, which would end up being a positive 144, right? Minus 4 times a times c over 2 times a. So, 12 plus or minus something over 8. Okay, that's 144, right? 4 times 4 is 16 times 9. 16 and 9. 4, 5, 144. So 144 minus 144, which would give us 0. Square root of 0. Not complaining about that one. So it would be basically positive or negative 12 over 8. Which would reduce to 3 over 2 or 1.5. But we'd have a positive version and a negative version of that. So we'd end up with x minus 1.5 and x plus 1.5. The other way you would think about that, you could go, because we're talking about the x-intercept, x would equal 3 over 2. You could times by 2 to get 2x equals 3, then subtract 3. So you'd end up with 2x minus 3 and 2x plus 3. Okay, which could fit into there as well. Okay, you could do it either way. For me, same thing. Okay, number 15. And we're almost out of time. Crap. So, what I'm going to do is I'm just going to hurry and solve this one out. So you guys can pause it and just kind of take a look at it. This would give us x squared equals negative 1, square root it. X would equal plus or minus I, basically 1i, which would be I. So the factors would be x minus I, x plus I. For this guy, would it work? No, so that one we definitely would have to use the quadratic formula. So 2 plus or minus square root of. And I'm going to pause it here and work out the problem. Okay, so looking at this, we found under here that we had square root of negative 8, 4 minus 12, which gave us 2i square root of 2. So 2 over 2, those 2's can all cancel out. So we've got 1 plus or minus I root 2, which we turn into the factor. And that is what we would end up with for our answer. And we're out of time.